Hello friends, this video on aldehyde ketones carboxylic acid part 26 is brought to you by examfear.com. No more fear from exam. So now let's start with the preparation methods for carboxylic acid. We'll prepare the carboxylic acid from primary alcohols and aldehydes. We'll also prepare it from alkyl benzenes. We'll prepare from nitriles and amides. We'll prepare it from Grignard reagents. We'll prepare it from acyl halides and anhydrides. We'll prepare from esters. And we'll also prepare from oxidation of hydrocarbons. So we'll use all these methods to prepare carboxylic acid. So let's start with the first methods to prepare carboxylic acid from alcohol and aldehyde. So as I told you, the thing it is alkane. From alkane you get alcohol. If you keep oxidizing it, then you get aldehydes or ketones. You further oxidize it, you get carboxylic acid. So we are trying now from this aldehydes to carboxylic acid. We'll do oxidation. To do that, we can use strong oxidizing agent also, because carboxylic acid will not further oxidize, right? Even weak will do, but strong is better because we have strong oxidizing agent, it will oxidize to carboxylic acid. In fact, I think weak will not help. Weak will not help. Only we have to use strong oxidizing agent. Correct? If you use strong oxidizing agent, for example, KMnO4, CrO3, H2SO4, there are so many ways we can do. So you have alcohols and aldehydes. You take any, you're trying from here to here also and here to here also. You take alcohols or aldehydes, use strong oxidizing agent, you get carboxylic acid. For example, you have RCH2OH, this is alcohol, you use KMnO4, then you hydrolyze. In the next step you get RCOOH. Correct? With aldehydes, I think mild oxidizing agent will help, but alcohols you need strong oxidizing agent. With aldehydes, I think this step you can use mild, but for this, because it has to go from alcohol all the way to carboxylic acid, you need strong oxidizing agent. The next is from alkylbenzene. So here we need to do a vigorous oxidation of alkylbenzene. Vigorous oxidation of alkylbenzene. So in this case, no matter what is the length of the chain, it will become what? Benzoic acid. See, even if you take this CH3, or you take, let's suppose, C2H5, or you take a bigger chain, doesn't matter. In all these cases, if you use strong oxidizing agent, right? Example, KMnO4, heat, what you get, and the next is this first step. Second step, you have to do hydrolysis with water, right? What you get is benzoic acid. This is what you'll get, right? And in this case, my 1 degree or 2 degree alkyl group is required. This is 1 degree or 2 degree. 3 degree alkyl group is not possible because it has to have some hydrogen, right? So 1 degree or 2 degree alkyl group. It doesn't matter how long is the chain, how small is the chain, it will just oxidize and becomes benzoic acid. Correct? So you can use oxidizing agent like chromic acid or acidic or alkaline KMnO4. You can use strong oxidizing, very strong oxidizing agent, because a vigorous oxidation is required here. The next is you have to prepare carboxylic acid from nitrile and amide. So in this case, nitriles are first hydrolyzed to amides and then to acids in the presence of H plus or OH. For example, I have my RCN. So first it will becomes RCONH2, and then when further hydrolysis and heat, it becomes RCOOH. So let's see the reaction mechanism of this. So I have RCN, RC triple bond N, H plus attacks here. Since nitrogen has the lone pair of electron, it will attack this and the bond will break in this fashion. Carbon gets a positive charge, NH. Now carbon gets a positive charge. I have H2O or OH minus you can take, or let's suppose I have H2O. Oxygen gets attracted to this. So now with this what you get is RCOH, and with oxygen I get a positive charge. Oxygen doesn't like positive charge, so this hydrogen will leave, right? Will leave, and this H plus will be attracted again by this nitrogen. So what will form is RC double bond NH. Since nitrogen is giving electron to hydrogen, get a positive charge, and this becomes OH. Correct? That's how it is. Yes. Nitrogen is not very happy with the positive charge. What it will do is, it will either kick this hydrogen, but it won't. Just now it has got this hydrogen, or it will ask oxygen to kick this hydrogen. So oxygen will kick this hydrogen. Oxygen gets a negative charge, and it will break this bond actually, right? So it will break this bond, and this lone pair of electron will go in this direction, form a bond, and this bond will also break. So nitrogen will get neutralized. So with this you get RCNH2, and there is a double bond. Correct? That's how you get. Now on this you again add water. Sorry, H plus. So H plus again, this will be attracted by this nitrogen. Again it will form RCONH3 with a positive charge, but it won't like the positive charge. So what will happen is, so with this NH3 will leave, this bond will break actually. NH3 will leave. NH3 is a good leaving group. This bond will break and carbon will get a positive charge. The bond will break in this fashion. So we get RCO with a positive charge, and there now OH minus ion will come, or you can take H2O also and come. Somehow it will mix and it becomes RCOH. If you want, you can take H2O and then oxygen comes here and then hydrogen goes off. That also you can do, or you can just add OH minus and you get RCOH. That is the reaction mechanism. Now we'll see the preparation of carboxylic acid from Grignard region. So in this case what we do is, we take this Grignard region and then we react with CO2, that is dry ice, used in refrigerator, dry ice, and what we get is salt of carboxylic acid, and then we do acidification of this to get carboxylic acid. I can show you one example. For example, I have RMgX, I have CO, right? This dry ether. What will happen is, slightly negative charge, slightly positive charge. R has negative charge in RMgX, you know that. To attack this carbon, this oxygen will attack this MgX. So with this you get is O minus, you get R here, you get double bond O, and here you get MgX. Correct? This is what you get. That is, if I want, I can write it properly once again. RCOOMgX. Correct? This is nothing but salt of carboxylic acid. On this, you do H3O plus. What happens is this H plus will be attacked by this guy, and this bond will break, and you'll get RCOH. And this MgX will become MgX and OH. This is what you'll get. So here you get final carboxylic acid from Grignard reagent. The next is from acyl halide. Thank you. Visit our website examfear.com to watch more and more quality educational videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.